I think, yeah, let me tell you, before we start, right? I think the context of this presentation, or the whole theme of the conference, is about generative AI and LLMs. So it's more about La La Land and the pursuit of happiness, well scripted dialogues. But here I am presenting about Jason Bourne kind of a movie, because the way deep learning or artificial intelligence evolved, the way it transformed the video data, it it changed a lot of things. I will tell you with an example that in a day, in a day, Google receives nearly 8.5 billion search queries. Okay, in a day. That means we have nearly 8.1 billion population in the world, and every person can send one Google request. But if you take a video analytics, where I'm talking about live video analytics, where the live videos are streaming and we do the processing. So if an IP camera runs at 20 FPS, in a day it generates 1.7 million frames, which is almost like 17 lakhs frames. If you round it off to 2, let's say 2 million, then exactly 4,000 cameras creates 8 billion images for inference. That means 4,000 cameras. Can you guess how many IP cameras there in the world right now? Can anyone guess a number? Exactly. So surveillance cameras alone, there are 1 billion. So that is the amount of data that are coming. So that's a context. Okay. Now, yeah, I can get started. So the topic of my presentation is transformation of computer vision and its effect on video analytics. Okay, so this is my overview about the presentation, where I come from an academic background, to be honest. Like, I did my PhD in image processing, so I am more inclined to present in that way. So status of AI in academic and industrial perspective, I'll give an overview, and then what is the current way, how the video analytics is transforming, how the computer vision is transforming. I'll give you a perspective on that, and then I'll talk about the future possibilities. That includes Gen AI. Okay. So here, in PwC, I come across a decent article, a study that calls like PwC AI Index. Okay, there they have defined like how many ways AI is used. So the interesting thing is they named it such that all comes AI itself. Like, there are, based on the human intervention and based on the system adaptability, we can divide the whole AI environment, AI capabilities, into 4 sections. One is called automated intelligence, and second is called assistant intelligence, third one is called augmented intelligence, and fourth is called autonomous intelligence. So automated intelligence is more like doing repetitive tasks. Like, if you take a barcode reading, so a human can do a barcode reading, and if you keep a camera, and if the camera has a capability to decode the barcode, it is an automated. So that is an automated intelligence. Whereas assisted intelligence is when there is no human involved. So when there is no human involved, so assisted intelligence is more like, we can say there are, let's say Chat GPT can be assisted intelligence. If you don't have any idea, it can assist you. It can refine you something. Let's say if you have a mail that you want to send and you want to refine it, it can assist you on that. That is assistive intelligence. Now, in the same way, there is an augmented intelligence, which is like it can completely generate a new thing. That is called augmented. So helping people to make better decisions. And the last one is called autonomous intelligence. Autonomous intelligence is where the system evolves itself. So there is a recent work that has done by both Google and NVIDIA, where NVIDIA used models to define hardware architectures such that the models will perform better. It will learn faster. Same way, the recent LLM models, which are developed by Google, used its own data to refine the model better. Okay, so that means self-learning. Now, I also added one more thing called D and G. So I think you can understand, like, so D means descriptive or a decision. Okay, decision or discriminative AI. not descriptive. Decision or discriminative AI, and G stands for generative AI. That means if you divide based on the application, you can divide into 4 categories. Based on its nature, whether it's a discriminative or it's a generative, you can divide into whole thing into 2 types. Okay, so this automated intelligence and automated intelligence is purely discriminative. So it doesn't generate anything, it doesn't create anything. But whereas assistant intelligence and augmented intelligence can have both kind of AIs. It can have both descriptive AI, discriminative AI, as well as it can have generative AI. Whereas autonomous, it's purely evolving itself. So I put it as mainly G. So this is a current status of AI in R&D field. Like the number of publications that happened as per the Stanford AI Index report 2023, there is nearly 496,000 papers that got published. So you can see the trend, like how it is evolving. And the most number of publications are from AI field, not AI in the sense, like if you observe these years, right, these years, from 2010 to nearly 2016-17, it was pure AI. There is no application. But since 2018-19 going forward, the applications started. Like if you take any science field, any medical field, people started using AI, and they started writing papers. People started using in manufacturing, people started using. In mechanical engineering, people started using. So the application areas got increased, so that the number of publications, everything got increased. Now, this is the status of AI in industry. So last year, as per the same Stanford AI Index report, nearly, you can see the number of projects that got adapted in the industry. Like all the industries, computer vision projects alone have 34%. Then in one way or other, people are adapting. People are accepting AI as a tool that can be useful in industries. Okay, I am coming from an industrial background, meaning most of our video analytics we do with industries, primarily with manufacturing industries and with logistic industry. And it's a B2B. Now, this is very encouraging to us because people started accepting the fact that AI will give a reliable results. Earlier, when we were in 2018-19, we call it POC era. So mostly it was more about how do we prove the concept, but it's not about how do we produce the concept, how do we productionize that. It was more about how do you prove. But now people are starting to believe in that, and they started to implement in a production level. Now this is a impact of those two works, like the R&D that happened and the amount of adaptability that happened in the industry. As per the PwC study 2023, there is an expected 50% gain in 2020 will come from consumption side. So basically the productivity of all the fields, especially productivity of operators, will increase by nearly 50% because of AI. I'm not talking about video analytics per se. Across all the fields, all the AI fields, there will be 50% gain. Especially in labor productivity, the amount of gain will be large. And this is interesting because most of the labor works in manufacturing, logistics, in those areas. So the expectation is like now whatever, consumer level analytics or consumer level applications that already reaching its saturation. So people are trying to identify new ways to develop or customize. So they're trying to develop very customized solutions for the end users. But the end users quantity is limited. Whereas in labor productivity, it's an untapped one. So the people are expecting like the labor productivity will improve because of AI the coming years. Now, as I told you, all the happy parts, these are the top challenges which are faced by AI as per the same Stanford University report. So here if you see, to start the business, proving business value is difficult for 37% of the projects. Okay, proving business value, that means they need to find a value in that. Now the lack of execution commitment and choosing the right AI technologies. So even now people are not confident like how to choose correct technologies to solve their existing problems. And for existing products to scale it up, they feel like managing AI related risks are 50% and obtaining needed data or inputs to train the models. So training in the models or developing AI solutions for for any industry per se is very challenging, and that actually comes out in that report as well. And implementing new technologies and proving business value again is a major challenge. Okay. Now comes to my topic, which is computer vision and video analytics. So computer vision is, I think, how many of you worked on either computer vision or video analytics? Yeah, good. This is nice to see so many vision developers. So computer vision is like it can deal with any image data. It can be video, it can be image, anything. Primarily, it can it can identify, it can do the required job on a image data, image or videos. But whereas in video analytics, it is a process of automatically analyzing video streams, and it can detect, track and interpret objects, events or patterns within the video data. So video data alone. When I mention video analytics, it's mostly about live videos. Okay, it's not a stored video. In computer vision, it can be a stored image. Like image enhancement will come under computer vision problem. But tracking a person or tracking the traffic comes under video analytics. Now, the transformation of computer vision, how it got evolved over time because of AI. Because I have seen, like from 2018, even much before, like since 2014, I am working with images. Okay, I have seen how the transformation happened. Earlier, to develop any solution, you have to rely on conventional, traditional approaches, where even if a slight light changes, if somebody turns on a bulb, the outputs will change. If somebody turns off the bulb, outputs will change. If somebody comes with a different color, outputs will, everything will dependent. And you need to descriptive analysis. That means you need to define every property of the task to get accurate results. And it is very sensitive to the environment. And most of it uses CPU earlier. Now, after coming the GPUs, after coming with the new deep learning models, that in other words called predictive analysis, where we started predicting things instead of descriptively detecting. So the things started changing. So I can give you an example. Maybe the example you can see. So here if you see, this is a CTG231. Assume this will be one complete image. That means there will be a camera which is focusing maybe a 2-inch height and a 4-inch width length area, just that area alone, and only text will come. Once you have the text, then these many processes it happens on a conventional way. That means first you will convert that into grayscale, then into thresholding, and then once you get the threshold values, you will separate them into individual elements. After that, you will use another descriptor, some model, to identify the letters. Okay, it involves this many, and the area, main area is 2 by 4 or 4 by 4 inches. But when it comes to deep learning, the field of view got increased. That means now I can use a camera. I can just focus all of you, and I can use a model to detect all of you. May not be recognize everyone, but I can detect all of you, all of your faces. I can detect. I can say like approximately how many number of people are there, how many number of empty seats are there. But with a descriptive approach, I can't do, because it won't give anything. Now, because of this evolution, the video analytics got also transformed. So if I tell you video analytics as a general thing, many people think like sci-fi movie, like okay, you can track people, you can see the existing data, and then you can say like okay, this event happened, that event happened. But the problem is, earlier, before before deep learning, most of the video analytics has been done by manually. That means if something happens, video will be recorded. So because of that incident or accident, people will go through that video footage and then they will analyze. And the only area that I see people are using techniques are to optimize the storage. Let's say if there is no person or anything here, then I don't have to save the video. That is one application of existing video analytics. That means if rarely somebody comes, then we can use some detection sensor, motion detection technique to identify, okay, there is some presence here. So I will save only that footage. I won't save the rest. That is one. And the second thing is, in night times, the camera will move to IR mode, can change to IR mode. So based on the light intensity, it can change to another mode. Those are the applications, basic. But after after deep learning, once we started predictive analysis, the things started changing. Now, so from storage optimization to we started doing enhanced analytics. Okay, and from simple triggers like motion detection to we started complex triggers. That means we can now actually see like how many people are coming with PPE. If somebody is entering, how many are coming with shoes, how many are not entering with shoes. We can detect immediately. If the trigger is, if somebody is coming without shoe, we need to alert, we can alert. And it is all customizable. Now, manual inspection to automated inspection. That means, as I told you earlier, you don't have to keep so many security people or employees to monitor the screens to identify any violation or any events. You can define everything, and then if there is any such event comes, automatically that will be recognized, detected and alerted. Now, reactive measures to proactive measures. This is very important. Like especially in manufacturing and logistics sectors. Not only in that, but even in road safety. So some areas some areas are prone to accidents. So there won't be any accidents, but there will be many incidents which can cause accident. Okay, so if you define those incidents early, let's say if we develop some algorithm which can detect those incidents, then we can easily identify those prone areas and we can avoid the accidents, which is like a proactive instead of a reactive approach. Now, so this is how the progression happened. Okay, the progression happened from, so this is whatever I told you, it's all on application level, but on a development level, from after the video analytics, this is how it is moving. Okay, from model centric to data centric, because in 2018 when I started my first job, right, it was more about TensorFlow models you will download and then you will deploy, you do a POC, but you will get maybe 100 or 200 images. It works on those images, but when you try on new images, it won't work. And second thing is, you need a very high-end GPU to run that model. You won't get you can't run it on a cheap model. But right now what happened, the models are becoming more and more smaller. The models are becoming more and more smaller, and the development cycles also coming smaller. You don't have the luxury, or we don't have the luxury to collect data for 1 month and do the training for 1 more month and then test it after 3rd month. You can't do that. Right now we are progressing towards smaller, very highly optimized models where you should use very minimal data, you should use minimal time. Like right now with our current implementations in Camera, we can actually collect data, clean, annotate, train and test within a week. The two very sophisticated high-end optimized models, and which can run on edge devices. Okay, most of our applications run on edge devices because the environment where we operate doesn't have the good internet connectivity, one thing, and the second thing is to maintain the security and privacy laws, we need to do the compute on-prem. So, and that's the second, and technically also the amount of data we need to transfer to cloud. In case of IP cameras, as I told you, that in one day it sends nearly 1.7 million images per camera. If you are talking about 100 cameras, that is almost like 170 million images. So those many images, if you want to transfer, you need a lot of time. Okay, so this is a traditional video analytics pipeline looks like earlier. So it's a rule-based system where we can do motion detection, object tracking, and foreground background, this one. But when it comes to the AI-based video analytics, you can do a lot. Okay, and on top of it, we can define some basic rules, which we can call this one as a business logic. This is a capability, this is a business logic. And then So this is a area where I will coincide with the current topic, which is generative AI. So now the problem is there are these models and which can give the data, but we can't meaning the models are very concentrated. That means if you want to track persons, you can have a person model, but you can't generalize that to everything. So that's when there is a Gen AI based architecture that we can come up with the pipeline where 2 minutes I'll conclude. I think I started late. Okay. So this is all these things can be done with using a single model, but the current limitation is it takes a lot of computation. Okay, that is a major issue. Now the second thing that I feel practical is you can use different models and you can use the Gen AI models or multi-mode models to analyze the data and give the inference. So that way the heavy lifting will be done using a point models on the cloud without much hardware requirements, but the analytics on top of it can be taken care by the advanced models. So that's why I didn't put Gen AI, I put advanced models. Now these are with respect to video analytics and computer vision, these are the present use cases I can see, which is like image generation, video generation, but these two things doesn't really helpful in video analytics, and exploratory data analysis for high dimensional data sets, and image enhancement and advanced data annotation, like segmentation in SAM model you might have heard. So it can annotate anything. You can, but I tried, but on complex data sets, complex environments, it won't work. It won't work. So, and the art of possibilities wise, there are few, like visual question answering. It's like when you have an image, the model can give you answer. And the interesting fact is actually as per the report, there is a latest model which has an accuracy of 82%, whereas the benchmark of human benchmark is 80% accuracy on a one standard data set. That means with respect to visual question answering, the models are able to interpret better or more accurately compared to the human. But whereas in visual common sense reasoning, that means it will give the answer, but this one can actually give you the reason behind the answer. So that one models lack a little. Now video generation and these are all there. So this is a point I talked about. So visual question reasoning as per the Stanford AI index. So you can see this is a benchmark 80.78, but whereas the model got almost 84.30. And this is visual common sense reasoning where the model is not that far. That's it, guys. I think if you have any questions.